So for silicon, the potential is 0.7. Okay. For germanium, the potential, this is called what? Barrier potential. You can take this value. Okay. Now use this formula here. Then you can write I equal to how much? I equal to 1.5 minus germanium 0.3 by R 10 ohms plus RF is not given 0. Then you can write 1.2 by 10 or not. So you can write like this, 0.12 amperes. Okay. Next, third one. See here, how much amount of resistance in this circuit, how much amount of resistance will flows, or otherwise if it is 8 volt, then how much amount of current will pass through the circuit. See, this is the plus, this is the minus or not. This is the P side and N side. Okay. Now this terminal is connected to positive terminal of the battery. P side is connected both to positive terminal of the battery, and N side is connected to negative terminal of the battery. Then that is said to be forward bias. So both the diodes, this and this, are said to be in a forward bias. So when they are in forward bias, both will work. Both will work means they are said to be in the parallel combination. In the parallel combination, then you can write 1 by R1 plus 1 by R2 equal to 1 by R. So 4 by 2, you will get 2. So I equal to how much? E by R. E is 8 volt. R value is 2 ohms. Okay. So 8 by 2, 4 amperes. 4 amperes. This diode is also said to be in the forward bias. Now see here, this is the P side and this is the N side. Here, this is the N side, this is the P side. Then this diode is said to be in the, first diode is said to be in the forward bias. Second diode is said to be in the reverse bias. So the reverse bias will not work. The reverse bias will not work. So only forward bias resistance is how much? 4 ohms. So I equal to 8 by 4, that is 2 amperes. Okay, 2 amperes. Next, if the diode forward resistance is given as 0.8 ohms, 0.8 ohms, this is 2.2 kilo ohms. Then you can write I equal to 8 minus, for silicon we wrote 0.7. So 0.7 by 2.2 kilo, kilo means 1000, plus 0.8. Like that you will write. Next, for fifth problem, see, this is the silicon diode and this is the germanium diode. They are said to be in the series or not? They are said to be in the series combination. So this is how much? 0 volt. What is the potential difference? You can write I is equal to 12 minus, for silicon 0.7 minus, for germanium 0.3 minus, for N side 0 by 5k. K means kilo. So you will get 12 minus 1, 11. 11 by 5k. So 11 by 5 means 5 twos 2.2 milli amperes. 2.2 milli amperes. For example, this is the silicon and this is also silicon. Here they are said to be in the series combination. They are said to be in the parallel combination. In parallel combination, only one diode will work. If both are silicon or both are germanium, then only in parallel potential is constant. That's why only you can take single potential. So A is equal to 10 minus 0.7 by 2k. That means 9.3 by 2k. That means 4.65 milli amperes. Okay. Next. So this is the circuit which contains two resistance. Two resistance 30 and 30. Here they are given two cases. If A, potential across the A is more than B, potential across A less than B. Find the effective current they are asking. What I told to you, if potential, this is a P side or not? If potential across the P side is more than potential across the P side, this is said to be, this P type terminal is connected to positive terminal of the battery and N is connected to negative terminal of the battery, then it is said to be forward bias. Okay. So now the diode is said to be in the forward bias in this case. Okay. So forward bias means it will work. It will work means this resistance will work, this resistance also will work. So both are working means these two are in parallel. So these two are in parallel means effective resistance is equal to how much? 30 by 2. That is 15. Okay. Now current from Ohm's law E equal to E by R. E is how much? 100 by 15. That is in the first case. In the second case, what they given? VA less than VB. VA less than VB means this diode, these symbols will be rotated, reverse. Then this diode will be in the reverse bias. In the reverse bias, this diode not work. Diode will not work. And the diode is not working means this line will not connected to the circuit. Only how much amount of resistance is present? 30 ohms resistance is present. So you can write I is equal to 100 by 30, that is 10 by 3 amperes. Okay. That is about that problem. Next, see these diodes. This is a plus and minus. This is BN. This is NP. These are connected in series. So it is said to be in forward bias. It is said to be in reverse bias. So from this, the current will move up to this point. But this is said to be in the reverse bias. So there is no current pass through the circuit. That's why the current across the circuit is 0. Next, see here, what is the difference between these two? This one and this one means here both the diodes are same, silicon. But here I am taking different, silicon and germanium. So silicon and germanium means the potential across the silicon is 0.7 volt. This is 0.3 volt. So the current always prefers the least potential path. That's why you can write I is equal to V minus E minus VB by R plus RF. E is how much? 10 minus barrier potential least is 0.3 by R value is 2K, means 9.7 by 2K. 9.7 by 2K. So you get 4.85 milliamperes. Okay. Thank you for watching. Please subscribe my channel Sri Sai Physics for Mains and NEET.